Okay, moving on to our evaluating problem. It wants us to use 2 for the variable s and -3 for the variable t. A note about negatives. When you plug negative in, please use parentheses. When you plug negatives in, you probably should even use parentheses for positives, but really you gotta use parentheses when you plug in negatives. So I'm going to carry down my 3. The s is going to be a 2, so I have 3 times 2 and then to the 3rd power, because that's what s was. It was to the 3rd power. And then I get the letter t, which is a -3, and that's the -2 power. Okay? I used parentheses when I had a negative, and this is all multiplication. First thing I'm going to do is rewrite this so like the negative exponent is taken care of. The 3 is happy on the top, and the 2 to the 3rd is happy on the top. But the -3 needs a positive exponent, so it needs to be moved to the bottom. Well, on the top, that becomes 3 times 2 to the +3, and on the bottom, that becomes -3 times -3. Yes, the negative gets the exponent because it was part of the squared. So that's 3 times 8, so 3 times 8 is 24, and on the bottom becomes a +9. Now something we should notice is that we can reduce, right? 3 goes into both 24 and 9, so I get 8/3 as my final answer. If you wanted to at the beginning, you could have simplified first. You could have started by putting the t to the +2 power on the bottom, and then you could have jumped to that step. I don't care which way, if you want to simplify first and then plug stuff in. It doesn't matter to me as long as you do it properly. Moving along pretty fast. Let's try the 3 got it's now, okay? These are evaluating problems. We got 4 got it's. What is the value of each? N is -2. You better use parentheses when you plug that in, and W is 5. So I'm going to fix this one first. Okay, let's watch how I'm going to fix this first before I start plugging numbers in. I know that the W to the 0 is happy where it is, and that the N to the 4 needs to be moved to the bottom. I also know that W to the 0 is 1, and N to the 4 stays as it is. That might help you when you start to plug stuff in now. That becomes 1 over, that's ugly, let me try again. That becomes 1 over -2 to the 4th power. Well, that's going to be 1 over -2 times -2 times -2 times -2 is a +16. Part B. Do you see how n has a -1? I'm going to fix this first. You don't have to fix it, but I'm going to. That leaves a 1 in the numerator because the W squared is happy in the bottom. The n to the first goes down below, and the W squared goes down below. Now you don't have to write the first power because the first power is always implied. So that's 1 over n is -2, and W is 5, and that needs a squared. So this becomes 1 over -2 times 25. Final answer, that's -1/50th. Because the negative don't keep that negative in the bottom, bring it out front or put it up top. Okay? Let's move on. We have part C now. Can you fix anything in part C? Absolutely. The n to the 0 can become a 1, and the W to the 6 stays where it was. So I get 1 over 5 to the 6th power, which I cannot do in my head. So 5 to the 6th power is 15,625. See, I had to cheat. I used my calculator. So I get 1 over 15,625 as my final reduced answer. The last problem we need to evaluate, okay, is this one right here. The W is not happy on the bottom, so he needs to move to the top and join the 1. Now you can write the 1 in the top, but I hope you know that 1 times anything is just that anything. So this is really, let's see if I can fit it in. This is really a W to the 1st power over an N. Okay? So W to the 1st power would be 5 to the 1st power, or just 5, and N is a -2. Please don't keep your negatives in the bottom. Your college professors are going to want you to put it out front or on the top. Out front is preferable. Okay. The last question here is part E. It says, is it easier to simplify it first or should you substitute first? That is a personal preference. I believe, personally, I think it's easier, like this problem in particular. See how it says N0, W0? This one is definitely going to be easier to simplify first because N to the 0 is 1 and W to the 0 is 1. So really I just have 1 times 1, which is 1. It doesn't matter what the heck I'm plugging in. 1 times 1 will always be a 1. Problem 4. A population of marine bacteria, that's kind of gross, doubles every hour under a controlled laboratory conditions. The number of bacteria is modeled by the expression 1000 times 2 to the h power, where h is how many hours after the scientist measures the population size. This is kind of gross. Bacteria is growing. Ew. Evaluate the expression at h equals 0 and at h equals -3. What does the value of these expressions even mean in this situation? Okay. Well, they did give us our expression. They said that it's 1000 times 2 to the h. They told us this equation models the population of bacteria. Okay, and they're saying that h is the number of hours after a scientist measures a population. So the first thing we're going to do is plug in when h is 0. So that's 1000 times 2 to the 0 power, which is just 1000 times 1, because anything to the 0 power. So that's just 1000 bacteria. Now let's plug in h equals -3. That's 1000 times 2 to the -3. That's 1000 over 2 to the +3, because anything to the negative power needs to move. That's 1000 over 8. And that equals 125 bacteria. So that one's actually smaller. Now, sometimes it's like, yeah, we can do the math, but what in the world did we just find out? All right, try to follow this. H equals 0 is when is, actually, let's say this, is 0 hours after the scientist measured the population. So what does that imply? That implies that if it's 0 hours after he measured the population, it implies it was his initial measurement. It's the first time he actually measured. When he measured, he found that it was the initial measurement was 1000 bacteria. That's what it means. H equals 0 is the initial measurement that he actually did. So what does h equals -3 mean? Well, if it's negative, that means that it's 3 hours prior to his initial measurement. Because it's negative. So 3 hours before he measured, or she, whatever, there was only 125 bacteria. And that makes sense. The bacteria is doubling, right? If you go back in time, there better not be as many. Okay? We got one more problem, and I think it's another fun word problem. Oh, good. Bacteria to insects. That's wonderful. A population of insects triples every week. The number of insects is modeled by the expression 5,400 times 3 to the W where W is the number of weeks after the population was measured. So they're not saying it's at the very beginning, it's just whenever somebody took the measurement. Evaluate the expression for -2 and 0 and 1. What does each value represent? Hopefully you kind of picked this up from the last problem. So let's plug in W equals -2. And before we do that, can we go ahead and just say what this means in words? Well, let's do that at the end. So 5,400 times 3 to the -2 is 5,400 over 3 to the +2, because of the rules we learned today. 5,400 divided by 9 is 600. Now, this is how many insects there was 2, and this is in weeks, 2 weeks. This is really gross, isn't it? 600 insects. Ew, that's not right. There were 600 insects. That's not proper English. 2 weeks before the initial measurement. Okay? That's because of the -2. Now let's plug in W equals 0. It's 5,400 times 3 to the 0. Your rule today says that's just 5,400 times 1. So that's just 5,400 insects measured, since it's at 0 weeks. So we're going to say, no, we're going to say at 0 weeks. We're going to say 5,400 insects measured at the initial measurement. Wonderful. Isn't that gross? Alright, last one is W equals 1. Okay, so it's 5,400 times 3 to the first power. No special thing here, it's just 5,400 times 3, because 3 to the first is 3. So 5,400 times 3, this is really gross, 16,200 insects. Now since this is a +1, this is there's 16,200 insects 1 week after, isn't that nasty, initial measurement. Okay. If you want to try some of these lesson checks and see how you do and see if the lesson kind of came together for you, go for it. If you have any questions, please jot them down so we can go over them tomorrow. Otherwise, have a wonderful night.